All right, welcome back, everybody. We are at week 6. So we have one more week left of class. And then if you're new to my classes, we'll also probably be doing sometime in the near future a show and tell. So that'll be like 2 weeks after class usually. I'll post a poll to see what the best time is for everybody. But essentially, that's once you've had time to explore all the material, you'll have a couple weeks to maybe work on a little project for yourself. I find it's a nice motivator to actually sort of apply a lot of these ideas and things we were looking at. And we'll continue doing the co-working sessions up until then as well, so that you'll be able to ask questions of me, maybe get help for projects you have ideas for, that sort of thing. And those show and tells are pretty low key. Like you shouldn't feel like you have to like do every single thing that we've covered in class, and you know feel like you have some amazing project you're ready to submit to some like research team or whatever. Like there's just like you show up, you say like, hey, here's some stuff I made over the past couple weeks, or I tried making a data set, it didn't go as well, but here's what I learned, right? Like a lot of this is just like you talking about what you did and what you learned, and that's like really the point of it. Because lots of people get a lot of valuable lessons out of that. Like even in failures, right? Like I try to tell you when I've failed at doing something because I think you can learn from that. Um, Also, if you're not a public speaker, record a video, share it with me, and I'll just play the recording. This doesn't need to be like pushing you to become a better public speaker or anything. It's just more an opportunity to share some work you're doing. So I'll announce that and like share more details with that probably more next week. Another thing is next week I do not have anything hard. Like there's no like hard and fast thing set up for next week. It's kind of just an open-ended opportunity to maybe share some additional stuff. So I have a couple ideas of things I could work on for next week if people are interested. But I'd also say if you've seen something that you know with StyleGAN and you're kind of interested in how someone made it or what it is, or maybe there's just something I haven't covered in this class yet that you would be interested in me talking about, let me know. Either drop a note in the chat today or drop a note over Slack in the next couple days. Usually I start preparing for this class over the weekend, so if you find something you like or are interested in learning more about and you let me know by like Friday or Saturday, I can usually cover that material. So maybe at the end of class, we can also talk about some stuff that might be of interest to people. I mentioned a little bit um, in I think a previous co-working session about some things we might look at, but open for that. Yes, and Grant, thank you. So there is also a co-working session tomorrow. It's at 8 o'clock my time, so that's 8 p.m. New York time. It's basically whatever the time usually is on Monday, except I moved it to Thursday because I couldn't do Monday. So there's one tomorrow, there is one Saturday afternoon, and then there'll be another one again Monday. So we've got 3 between now and next week. So maybe it's a great time to start thinking about maybe a project you might want to work on, and then coming to making one of those sessions if you can, and showing up and asking questions. As always, if you can't make one of those sessions, but you do have questions, please DM me. If we can't work it out over DM, we can always set up a time to just do a one-on-one quickly and try to cover stuff that way. So I'm always happy to help people with projects if they have one in mind. Cool. So let me share today's slides. So I got a little bit of slides and then some other stuff. And then maybe before we do that, let's talk about some of the work people shared this week. I know Varun, you were sharing some really cool stuff in the Slack, so maybe you can talk to us a little bit about what you were doing there.
Yeah, sure. I've been training my model on mesh gradients. Just been using that as an example for a few different things. And then this is just did a couple of examples of the audio reactive stuff. So um, it's kind of weird. Like it's just like blobs of color. So unlike some of the other models, it's hard to figure out what the vectors do. So it's just a lot of random experimentation, picking stuff that I kind of liked. I ended up doing like just like picking random seeds that kind of look good and then sorting them to kind of find stuff that was different enough to pick 12 that could create images that had somewhat contrast in it. And this is something that I ended up with so far. I'm going to play around a little bit more and see what else I can do with this.
Yeah, I'm really enjoying watching your progress on this model. It's sort of funny, like I've said this before in other classes, but I'll always Like if someone were to come to me and say like, "Hey, I just want to do a thing on mesh gradients," I'd be like, I don't know that StyleGAN's gonna like either one work for that or find anything interesting in it. But then watching all your work, I'm like, actually, this looks really amazing. Like I think there's some really cool things that even if it's super abstract like this, I think just seeing it sort of move to the beat. And sorry, I don't have sound on, just so that everyone could talk, but I do recommend checking out the video in Slack so you can actually hear it. Just sort of seeing even gradients move, which again is not something that we like traditionally see happen. I think it's really interesting. So yeah, I've really enjoyed seeing your progress so far.
Thanks.
And one of the funny things is I would have expected it, even training this model, I would have maybe expected it to sort of turn to mush, because I think like StyleGAN is generally like designed to sort of find these patterns at certain layers, which we'll talk about more today. That I am pretty amazed at how well it rendered all those various meshes. How many mesh images did you have, by the way?
Oh, close to 1,000.
Okay, yeah, so pretty good. Yeah, so only 1,000 images to be able to make something that looks that interesting. And I think, again, I always find the challenge of like, well, should I do audio active meshes in Touch Designer or should they do them in StyleGAN? It's like, I don't know that really matters. Like whatever you're most comfortable working in, right? So I think it's kind of interesting to sort of see how you can do so much with even just a really simple StyleGAN model, like some gradients. Let's see, I don't think there was too much else. Did anyone get to play with any audio active stuff and find that things worked or didn't work? Silence. Okay. Well, again, I would say like if there's anything out of the past like maybe 7 weeks of class, I think the audio reactive stuff is probably the most fun. So I would definitely encourage you to again even just take a pre-trained model, like take one of the models off of Justin Pinkney's site, or if there's a model you've seen of mine that you would like to borrow to do some audio reactive stuff, please just reach out to me because I'm happy to sort of share that work. And I think again, I think even the audio active, like having those 4 different layers and being able to connect them to different types of sound and that sort of thing, I think really shows the breadth of what StyleGAN can do. And I think we'll look at more of that today. All right, so I shared the notes already, or the slides for today. So we're going to be doing in today's class is we're going to be discussing StyleGAN layers. So I touched on this fairly briefly last week, maybe when we were talking about the noise layers in the audio active settings. StyleGAN uses an upscaling approach. The sort of historical part of StyleGAN is that in the, I don't know, probably 3 or 4 years ago now, there was a model called progressive growing of GANs, and that eventually became StyleGAN. And one of the challenges of GANs has always been how do we maintain stability while also getting high res outputs, right? I actually saw someone post a paper, a machine learning paper, maybe yesterday or the day before, that talked about high res GANs and how they had like solved doing high res GANs. And their idea of high res was 256 by 256 pixels. And again, in each world, like they sort of have their own idea of what high res equals. But it's certainly in the art world that is not even close to being high res. StyleGAN works very well up to 1024 or larger. I have experimented with doing like a little bit larger than 1024, and it can generally still hold a lot of detail. And that's like that's sort of up to like the way that the architecture of the StyleGAN model is built, that it is able to do that. And the way it does it is sort of go back. The progressive growing of GANs was the idea that you generate an image at a certain pixel size, and then you find a way to train the model to blow it up and to make it larger and larger and larger. And that progressive growing is how it stays so stable. And what they've sort of learned from that model is that, if you start with a relatively like good structural size at, 16 by 16 pixels, as you grow that structure, right, whatever the outline or the silhouette of that image is, can define sort of the structure of the image underneath it. And then as you add each layer, you get more and more detail and more sort of, texture and that sort of thing. So I'd say today, like StyleGAN is probably still one of your best models if you're looking for purely resolution-based outputs. And you have like single items, right? Like I've started to notice that a lot of the the people doing clip guided models like VQGAN and other things have gotten to resolutions that are like fairly decent. Usually require a bigger GPU than 16 gigabytes, but you can do it. But the difference between like a clip model at like 1024 by 1024 and a StyleGAN model at 1024 by 1024 is the VQGAN that they use to do a lot of the clip work is it's still almost collagey, right? There's still lots of patches. You don't really get that single image you can get with StyleGAN. So again, like StyleGAN just as a whole, I would say is still one of the best models. If you're really looking for highly detailed, like single, image production, and it has so much to do with this network. And obviously it has to do with the fact that it takes a while to train versus other things that are a little bit faster, that sort of thing. But there's still a ton of power in StyleGAN and how it operates, and you're able to get good resolutions out of it. So I thought I'd quickly just sort of like show you what these resolutions are. And once you understand this, I think you also then begin to understand like a little bit of why it's required that certain things be certain resolutions, right? So when we've trained these models, it's either been you have to be 256 by 256 square, you have to be 512 by 512, or 1024 by 1024. And that's mostly because of this architecture. So we'll actually look at the layers and the layer names in just a minute in a Colab notebook. But the idea is that you actually start with something 4 by 4. So something as small as a 4 by 4, you can think about it pixels. Actually, what it is it's 4 by 4 times the 512 dimensions in your vector. But it's essentially like more or less we could visualize it as generating a 4 by 4 pixel image. That then gets scaled up to 8 by 8. That gets scaled up to 16 by 16. Up to 32, up to 64, up to 128, up to 256, up to, to 1024, right? So 256, it goes 256, 512, 1024. And that's essentially the process of these. There's these layers in the model, and each layer has a learned value. This is the machine learning part of how it's supposed to translate an image at 4 by 4 to 8 by 8. And actually, it's kind of cheating. There's actually 2 layers within each of these. One of those layers being the how do I upsize this thing. So there's actually double the amount minus, 4 by 4 only has 1. Getting a little in the weeds here. We'll look at this and actually look at the layers and understand a little bit more about how it works. But what's really fascinating here is that all of these layers have their own weights. And that means that they're actually sort of manipulable at the layer level. And most of what we're going to look at today is what can we do with these layers to manipulate them individually to get interesting results out of them. So we'll look at 2 techniques. One is called network blending, and then one is called network bending. And essentially, they're taking these networks, and they're taking specifically the layers, and they're doing different manipulations on each layer in order to affect our output image. And it's kind of funny, like, I think you can sort of like think of these as images at each scale, but they really aren't. They're just a collection of numbers. The final output really gives you your image, and that's where we convert those weights to something that a machine could read as pixel data. But in reality, just remember, like all of these are lots of numbers inside of them. It just happens that also images are made of lots of numbers in the way that machines read images. But in reality, most of this stuff is purely these weight-based systems inside of machine learning. And by weights, I just mean literally like they're just numbers. What it says is, it says like, hey, if I want to go from 32 by 32 to 64 by 64, that means at all of these places in the model, the math is, this value gets doubled, or this value gets, a decay rate on it or something. So all we're doing is we're translating from this very small value. Actually, we're translating from our vector value into this small value all the way up. And there's lots of different like things going on in this model, as we'll see in a minute, that determine how this gets output, right? Because we could say like, oh, well, I'll just put in a bunch of blue. How do we determine what blue gets turned out to like the sky versus clouds or that sort of thing? That's sort of the idea of what this machine is trying to learn or trying to be able to do from there. And lastly, I think I've mentioned this a couple of times, but I think it's just worth repeating because you'll see this actually being of value or of worth remembering as we work through this stuff. Anything at the smaller size is going to affect structure. Anything at the larger size is going to affect details. And again, the way I think about this is if you were to draw, a very small image on your 4x4 pixel, as you blow it up, really all you're left with is like sort of a silhouette from this size to here. So we get sort of that silhouette very early on in the model, and then as we add layer, we're adding texture and detail and more things, right? It's like looking at something from very, very far away and you make out the silhouette, but as it comes closer, you're able to make out more of the details in the image. Any questions about that before we jump into these examples?
Quick question, just out of curiosity. Is it
Yeah.
so when the model's training, is it downscaling? So if you fed it a bunch of 1024 by 1024 images, does it have some kind of downsizing process that it's doing as it's training to then be able to upscale again?
A little bit, yeah. I mean, one of the things, and we could actually, I mean, we haven't done this in this class, but we could actually look at the discriminator layers as well as the generator layers. And often you will see there's this like sort of, the generator is doing the upscaling and the discriminator is doing the downscaling. And that is essentially how it learns, right? So yeah, that's a good point that there is sort of both a downscaling and an upscaling. One of the things that's a little confusing is that previous versions of StyleGAN actually used to literally do upscaling and downscaling. So I think StyleGAN 1 and maybe StyleGAN 2, I think maybe just StyleGAN 1, but certainly Progressive GAN or ProGAN as well. When you started training it, you started training it from scratch, and it would literally start by just generating the 4x4s, and then it would move on to learn and generate 8x8s, and then it would generate 16x16s. That's an older architecture. The new architecture sort of does all the scaling all at once as it learns. So the training will actually produce something that looks more like a 1024 by 1024 image from the beginning. It's just like the resolution changes in a different way. But yeah, so there is sort of still this scaling process, but it's a little different than you might. Like I think about the scaling more as a metaphor now than I do as like the actual structure of how it learns. Cool. Any other questions? All right, so let's take a look at a real world example then. Let's look at model blending. So model blending is this concept of, okay, we have all these layers, right? And each model has the same layers, or if it's at least the same resolution, right? They're both 1024 by 1024 models. They each have the same layers, right? They all have 4x4, they all have 8x8, all the way up to 1024 by 1024. They also have weights that match up to each other at each of those layers. So one of the things we could potentially look at is what if we took half of the layers from one model and then took half of the layers from the other model and combined them, right? So that's what model blending essentially does. It just takes the layers, it chooses a point at where to split the two, and it says, okay, take all the lower layers from this model and all the higher layers from this model and combine them back together. Again, remember that all these things are just numbers, right? So you can just swap them in and out. So that's what model blending does. So an example of this would be, let's say I have, I always butcher the name ukiyo-e model of sort of Japanese drawings, and let's say you take that, you just take just the lower layers of this model, right? So we want just the structures. So that'll give us basically just the outlines of these shapes, the face shapes, maybe the eye shapes, maybe the hairlines, that sort of thing. And then I want to take FHQ and I want to apply just the higher level details. And what that's going to end up meaning is it's going to mean hair texture, skin texture, like a lot of textural things, and maybe some color as well. So if I were to blend these using this model blending technique, what would I end up with? I would end up with something that looked like this. So here you have almost this like almost 3D rendered sort of an illustration that takes the like structure of the underlying model, but applies another layer of sort of this like very realistic skin and hair texture on top of it. Obviously, these are sort of like the maybe slightly grosser examples or like uncanny valley examples, but that's what you get with this. And similarly, this technique was the first person I saw that was really doing it was Justin Pinkney, and I think one of his collaborators, Duran Adler. They were doing a thing, God, probably almost a year ago now, called Tunify. And you can go and find, actually, like I'll make a note to find one of their notebooks so people can play with it. So there was a thing called Tunify, and what they were able to do they could take a picture of you or someone you knew. They would project it into the FHQ model or another model, I guess maybe maybe like a Pixar or some sort of illustration model, and then they're able to use this network blending tool to actually generate sort of a Pixar 3D rendered, like highly detailed version of you, right? So it's sort of like they can figure out sort of how to map these two one-to-one. And today I see a ton of people making use of these tools. I think Justin and Duran were like some of the first people, and now everyone has sort of like aped that technique, and now it's available in TikTok and other like face photography tools, those sort of things. But that's essentially the concept, right? And there's probably a couple different ways you could do this, right? You could do it with a StyleGAN network blended model. Another way is like now that you've got these sort of pairs, you can maybe do something like a Munit or a StyleGAN model. There's probably lots of ways that people go about doing it today that isn't purely all StyleGAN. But I think this really showed the technique of like, you can really make something brand new by having two different models you can put together. And to me, that's sort of like the most interesting part of the machine learning art practice, is not just like, can we render really realistic faces, but more like, how can we make artistic choices in here? And I think this is a great example of how with just the models that you're training, you can create like some really artistic options by sort of combining textures and structures of different materials. So a couple notes about network blending as we go through and try this. In general, your first thought might be to just go grab two models off Justin Pinkney's awesome StyleGAN 2 models and just combine them. That's actually what I'm going to do for some of this demo, at least. I have found that results are very hit or miss with that. Part of the reason is that, again, think about these as weights that have been trained in a model. If you have a model of churches and a model of cats, the structures are very different, and even the textures are very different. And if you just throw them together, you're going to get a lot of noise and a lot of messiness. We'll actually look at those examples in a minute. I think what people have sort of found that works best as like any technique, if you want to go from any model to another model, is to actually do some transfer learning before you actually do that model split. And the process for that would be to choose one of your models, and then use that as your resume from, right? So when we looked at training, there's the resume from function. You can use that as your resume from, and then feed it your new data, right? So if I were to do this with churches and cats, I would train off of the churches for a little while with my cat data, maybe for half a day, maybe for a little bit longer. I'll show some examples of like how timing affects this. But essentially transfer learning, what that does is it takes all the weights from your church model, and then it transfers whatever it needs to the new model, but it will generally keep other stuff, things it doesn't need to alter in the old model. That way, when you actually do the model blending, more of the weights match up, and that's sort of helpful for future processes. The second tip, and one thing we'll look at a lot today, is also what exact layer are you splitting it at, right? You don't want to split it at the 4x4 layer, right? Because there's like no data there. You essentially have this very, very small place. What most people are generally doing is they could look at the 8x8, but I generally find between the 16x16 and the 128x128 model layers, like splitting at one of those layers is going to give you the best results. And the sooner you split it, so if you split the 16x16 model, say again in the churches versus cats idea, you're going to get more cat data, right? You'll get more of the cat textures, but you'll have very specific like church structures underneath it. The later you split it, so say you split it at 128, you'll keep more of the church data and less of the cat texture. So it's sort of important to think about where you shift this, you'll get different results. The nice thing is that it's fairly fast to do this process. So you should just do it and look at your various results and see what you get, because, it's just easier to sort of visualize it, and you'll be able to tell what works well and what doesn't. So as I mentioned, here are examples of churches and cats. So this version on the left has the church model as the base model. So like that's the lower layers. And this one on the right has the cats as the lower layers. And this is 8x8, 16x16. I think it skips 32x32, so it's 64, 128. So 8, 16, 64, 128. And you'll see here that very early on, right, so this would be the 8x8. There's not a lot of well, there's not a lot of anything. This is just like two models have been thrown together. It's just very noisy. But I will say that there is a cat paw or two, like here. So there is some cat texture here in this one. As you get to the higher layers, you'll see like the noise is all over the place, but you can see the basics of these church structures. So again, remember that we're going from 4x4 to 128 with churches, and we actually keep most of the church stuff, and we don't see any real cat texture on top of this. Match that with on this side, we have the cat model. And again, you don't really see much here. I guess you see sky and maybe the outline of a church. So this one kind of has a little bit more of the church side. And once we got to the 128, we see a lot more cat, but like it almost looks like it's been run through a Photoshop filter. So this is a place of where like this clearly is not a good model, or these are clearly not two models you want to blend together unless you're like going for this look. Most people aren't. So this is what I would say is like not a good option. But what you could try to do is actually take the church model, do some transfer learning for like a handful of hours to the cat model, and then try this again and see if it works better. So I did this with one of my models, which is I took that geometric model we looked at last week during the audio active stuff, and then one of my flower models. So this example here was done, I don't know what I actually transfer learned this plant model off of, but it wasn't that geometric model. It might have been faces or something. And here's an example of what it looks like when you don't transfer learn. So this is 8, it's 8, 16, 32, 64, 128. One thing I notice here is that you see at each of these layers, you get very different results, right? So here I see a lot of yellow. Here I see green and pink. Here I just see a lot of noisy texture. Here it actually seems like the shape is missing, and here's nothing. Compare that to the one below, which actually does use transfer learning. So last week, I think this is maybe 8 hours of transfer learning or something. I did transfer learning, and you'll see here that even though the results are still fairly noisy at each of these levels, you get a little bit more of a consistent look as you go across this, right? There's red and green pretty much in every one of these images. And I think that's a good example of sort of like transfer learning clearly like learned something that adapts across both these models, even if it still looks pretty weird. Whereas this is sort of all over the place. So I do find that transfer learning gives you a little bit more cohesiveness or coherence as you go through these layers. And then I wanted to show this one was trained for 260K images. So that would have been, I guess, maybe 10 hours. And this one was trained for 488. So this would have been about 20 hours. So as you begin to do more transfer learning, your model will get further and further away from the previous data, right? So in this case, I would probably say this one looks, for me personally, this one looks better than this one does. These are the exact same seed values. So you'll see that this one feels a little bit more coherently like a mix of those two models, whereas this is starting to feel like it's a little bit, I don't know, a little bit less of like the shapes plus a flower texture. So this is, again, I might even try another one where I would try this with like maybe only 100K images into my transfer learn, just to sort of see how different they are, or like how close they need to be. So yeah, network blending takes a little bit of like sort of messing with things to see what's going to work best for you. The good news is that to do that transfer learning, you're talking about maybe a day of time on a Colab notebook, right? So you can definitely do that, overnight, and then come in and sort of like play with it a couple different layers and see what happens. Any questions before we jump into the notebook?
I had a quick question on that. What if you liked, so I kind of like the second to last image. Say you like the second to last one, that's kind of where you feel like the sweet spot is for the effect you're going for. Is there any kind of strategy you have to change your configuration to kind of stop at that point instead of continuing on to the next layer?
Yeah, that's a good question. Well, so like what we'll do is we'll actually render models at each of these stages. So basically we could look at one that's 8x8, 16x16, 32, 64, 128. So like we could actually just render out, like we could turn this into a pickle file. And that's what I recommend doing. So like you'll generally make a pickle file at any one of these places. Does that answer your question?
Yeah, that makes sense.
Okay, cool. Yeah, so we'll actually like this is, so I sort of agree. I think this was my favorite layer, or like my favorite result of this blend. So we could actually generate a new pickle file, and then once you've got a pickle file at this state, then we can go back and use all the generation tools. Like we can do interpolations, we can do W space, Z space, like that sort of thing with this exact model. Cool. Okay, so let's take a look at the notebook. Drop a link in here for everybody. All right, so obviously first thing we need to get started is just like sort of load up our notebook. Got to be 100, so hopefully things go quick today during demo. The nice thing about this thing is it's very fast. It doesn't take a lot of time to actually generate these. So once you've got your collab up and running, again, you could use this to, like, you connect to Drive if you wanted to. I won't, because I'm just going to download these models directly from the internet using wget. But if you wanted to sync to Google Drive, you could just add that cell in here and do that as well. So you do need two models. They must be the same size, so you can't grab a 256 model and a 1024 model. It just won't work that way. So I recommend, go on to either train two models yourself, or go on to like Justin Pinkney's awesome pre-trained models and grab a couple that are the same size. Yugaso isn't here right now, but or maybe she isn't. I just don't have everyone visible here. She ran into an issue last week where one of the models that she grabbed from the pre-trained site wasn't converting correctly. I think I've fixed all those issues, but if you do try to convert a model into the latest format and you run into issues, let me know. So I'm going to go ahead and just download two models. So what I'm going to do is I'm going to download FHQ, and then I'm going to download one of my cat models. This happens to be the Bone model that I've done in previous demos if you've been a part of those classes. So the first one is my local one, so it's going to come down on GDown. The other one is stored on some CloudFront site, so we'll just use wget to download those. And I left the church and cat configs in here. These are both 256 models, so if you want to play with those, you're welcome to. I left them in here. And because both of these models were trained using the non-PyTorch version, and by PyTorch version I mean the official PyTorch version, not the Rosinality PyTorch version, they need to be converted to the latest version of that PyTorch system. So this is that legacy.py script. So we're just going to run this cell, and what this will do is we'll just convert these models to the same format. All right. So we now have bonebone-pt and fhq-pt. I generally don't keep these models. It's because that process is so quick, I don't really worry about trying to save these into some place in Drive and taking up 700 megabytes of my files, right? Because I can just do this legacy convert. So there's, we can look at very quickly just how to run the script version of this. So I did add this week into my repo. You can now just run this from a single line command. So let's go ahead and run the help command just to look at what our options are. So you'll use the blendmodels.py script, and that takes in a couple options. The first is you need to pass in the lower res pickle. Now lower res you might assume means like, oh, that's a lower resolution. What that means is this is the model that you're going to base the lower resolution splits from. So in this case, what I'm going to do is I'm going to use FHQ as this. So I'll get the basic face structures, and then for the higher res pickle, I'm going to use the cat model. So I want the fine textures and details from my cat model for the higher res. So just remember that order matters here. If I were to flip them around, I would get like a cat structure with like a human skin. This is already going to be creepy enough, but I'll save you from having to look at that version. So yeah, just know that is those are your two options. Output path. So this is where do I save that pickle file and what do I name it? So let's just do this real quick here. Move these on to some new lines so it's a little bit more legible. Okay, so lower res, higher res, let me move some stuff around here. Lower res, higher res output path, and then the last option here is for split resolution. So at what layer of the model do I want to split? This should always be either 4, 8, 16, 32, 64, 128, 256, or 512. Sorry, and it shouldn't be 4. It should always be 8, 16. These are your options. If you put in a different number, it's not going to really know what to do. So make sure you use one of these options. Lastly, if you do have a model that is not 1024 by 1024, you'll want to pass in this model res and just set your size. It defaults to 1024, so you don't really need to worry about it if it's a 1024 model, but if you do have a 512 or 256 model, you'll want to pass in that size. So once you have that set up, I always recommend naming your model something that makes sense. So I usually add the size or the resolution layer at which I'm splitting this, just so I have access to it. So go ahead and run this. This should take no more than 30 seconds.
Does the split layer go to the lower side or the higher side?
That's a good question. I believe it goes to the higher side.
Cool.
Yeah, so it's like at the 64 is when you start picking up the higher side. The code is also a little below here, and we can double check that to make sure I'm right, but I'm fairly sure that's right. Yeah. So this will now generate a new pickle file for me. There it is, FHQ bone split 64. And then you can just go ahead and let's just grab this code here. So you can go ahead and generate some images from this. So we'll just say out FFHQ bone 64. And I want to make sure we reference this path. This will take a minute just to spin up those special CUDA operations, but then we should get images from here. So this is how you do it from the script version. Once we're done with this, I'm actually going to walk us through the code to actually see how it works and actually take a little bit of look under the hood. I would probably actually recommend the non-script version because we can do stuff like automate a bunch of batches of these and just spit out a bunch of them all at once. But if you're a little bit wary of doing coded stuff, like this is always an option for you. Here we go. So we're rendering. Sorry, these are going to be a little creepy. I'm just warning you now. So there is our person with some cat fur texture. There is a child. Man, there should be no children in FHQ. It's too creepy. All right, so there's another one. So I would say personally, like I would probably drop this layer down a little bit. Like I would actually lower it to like 32. I bet 32 works a little bit better. Again, part of this is just like each model, you're going to find different results using different layers. So I recommend playing with each of those within your own model. This is kind of a good one. You can see a little bit more of like the fur texture here. And even the hat gets some funny stuff happening to it. So it's a pretty interesting technique. So this is not a good one. Okay, sorry. By good, I meant it renders well. It may be creepy, but it renders well. So a lot of times, like I actually shared these on my Instagram last week, and people were like, "Oh, aren't you just doing transfer learning? Like, isn't this just like take FHQ and add the cat to it?" And it's actually slightly different. And I think it's important to highlight what those differences are, which is that transfer learning, as you do a transfer learning, you sort of get a similar process. What happens is all the layers are shifting over time. And so I would actually say like you wouldn't get the exact same results because you don't get the fixed layers at that smaller size plus the texture on top. So while you could get fairly similar results, I think they will be different enough, and you'll have a little bit more control here about saying, exactly what layer do I want to switch these things. So do you think it's kind of fun to try both and just see what you get? But yeah, it's a slightly different technique than just purely doing transfer learning. So let's actually take a look at the code really quickly here. So I'll go through all this. I'm just going to run this because this defines a bunch of functions. But I'm just going to start by running this, and then we'll walk through how to actually do this. So in this cell down here, what I've got are a couple variables. So there's low-res pickle, high-res pickle, model resolution, level, which I set to 0 for now. We'll look at how to change that. And then actually this is no longer used. And then where should I output this to? So let's go ahead and set up the variables for this here. So let's do bone for my high-res layers. Let's do FHQ for my other layers. lower layers, and it's still 1024. So what do we need to do? So the first process is, if we've gone through, if you remember this from back in the generating latents class or generating vectors class, first thing we need to do is actually need to load that pickle in. So we're going to load in that low res pickle. We'll load that in and we will save the files. Now, one of the things to note here is previously we just loaded in the GEMA, which is the something moving average. I can't exactly remember what E stands for. In this case, for the low res model, we're actually going to load in the generator, the discriminator, and this version. The difference between this E and this E, or sorry, this G and this G, this is a average of the past couple weight updates. So in general, people find this generates better images. This is the purely brand new generator trained model. The reason we do this is that when we want to save out our model, we actually want to save out both the generator and the discriminator. Now, the truth is you can't really, I wouldn't necessarily recommend you use that model to transfer learn off of, because those weights are split in weird ways. Doing transfer learning off is kind of funky, but I think we need to have the model have all those weights in it just to process it correctly. So just know that's what we're doing here. So we're just going to essentially what we're doing for this process, we're taking the lower model and we're just going to append a little bit of additional detail on top of it, or swap out a couple layers of data to make this work. So we'll load in our high-res pickle here as well. And this will, we will just use that GEMA or GEMA version. Let's actually delete that code there. Next is, at what point do we want to actually change or blend our models or split our models, right? So as I mentioned, there are a bunch of resolutions. In general, I find that these are pretty much the best range to try your model at. You could add 256 to this if you wanted to. The detail from 256 on is so minimal that it's kind of not really, I find that you don't generally get good results here, but we can leave it in and just look at it. So we're going to actually, what we're going to do is we're going to generate a single model, or we're going to generate a model at each one of these sizes. So instead of going up to here to my code and editing, okay, I want to do 8, and then run this, we're going to run a loop that will allow us to just go and generate all of these in one fell swoop. So we'll generate a model at each one of these layers. So this will go to a function that I've defined above. We'll look at that function before we run this. But essentially, we're going to say for every single resolution here, run this command and then save out the data. So we're going to change our name here. So this will create the process, and then we'll save out our file. And I want to save this out as blend-ffhq-bone. This R is a variable that references this. So the first time it runs, it's going to be 8, then it's going to be 16, 32, 64, 128, 256. So this is going to save out 1, 2, 3, 6 different models at all those sizes. And so we will create this path, and then we're going to save out all the data, and then we just save it to a pickle file. This is the code to save out each of those layers, or each of the generator, discriminator, and the average generator. So this is really where the good stuff happens. This is the blend models function, which I've defined up here. And what this does is it goes through our models. So the first thing it does is it just checks to make sure that all of the layers match. This is a good test case to assert. Basically says if that all of these don't match, throw an error message. So if you try to combine a 256 and a 1024 model, this will throw an error. If for whatever reason you forgot to convert one of your models using that legacy script, the names here might not match. So if you get an error with the names not matching, or you get some assertion error here, it may be that. So if you have 1024 models for both models, and you still get an error message, it might be that you need to make sure that you convert both of them using that legacy script, so that you make sure they're in the same format. So this just checks to make sure our layer names match. And then we make copies of the model. So as I mentioned, basically the idea here is that we take our low model, which is the low resolution. We basically make a copy of it, and then we replace those higher level layers with our new data, which is here. So this is basically running through our new model, param source. So param source is high. We'll look at this name parameters because it's actually really helpful to look at. this will tell you all the names of your layers. So basically, we're going to take all these layers, and then we're going to take the data out of them. So when the layer is, when we're supposed to split it 8, we will start at 8, and we'll copy all the data from the higher res model and move it over. And then we just return the model. So let's actually do this. Let's take a look at what our model name is. So I'm going to comment all this stuff out here. And I'm going to take this named parameters function. So named parameters function is a PyTorch function, meaning any model that has been produced in PyTorch, you can run this function on it. And this will return all of the names of your model, or like of the layers in your model. So let's actually take this high res, or the high resolution. This will be the bone layer, and let's print these out. So what we're going to do is we're going to say print. We're going to say for n in high.name parameters. So for all the names of the layers in our model, we're going to print n, and we want the first key. N has both, the first key is the name, and then the second key are the actual weights. So if you were to print out just n, actually let's just look at this. It's worth seeing what you get here. This might take a second to load. What you will get is a dump of all of the weights and the names of the weights. So the names of your layers are here, and then all of the weights are here. When we run this, we don't really want all these weights just because it's like a ton of numbers that don't really mean anything to us. So what I recommend you do is that you do print n and 0. And so here are all of the layers in this model. So what you'll see here is you'll see the synthesis, which is the generator, has a B4 and then a constant. So B4, this is where it takes in that vector. So it takes in the vector as a constant variable. Then there is, if you see conv, that means convolution. So we're doing some convolutions, meaning we're like manipulating that data. And then the last step usually before we do this is to convert it to an RGB. So here is all the layers of the B4 up to here. And then we switch to the B8, which is the 8x8 matrix, or the 8x8 image. Then we've got 16x16, 32x32. And remember that each one of these layers, or each one of these names, is essentially a variable that points to a bunch of weights. So when we run that script, we're actually matching up name to name, and then just swapping out the variables. And I'll also mention that there is the mapping network. The mapping network is actually how you convert things from Z to W. We don't actually, I don't think we mess with these variables at all, but somehow I think converting Z's to W still works, so it's kind of funky that, don't really ask me how that works. I guess maybe there's probably something that isn't, maybe it shouldn't work that way, but it does. So you'll see we basically are just swapping layers in and out between all these pieces. So now that you've sort of seen how that looks, let's actually go ahead and run this, and then we can sort of see how we produce a bunch of different models at different sizes. I should note that I don't actually use this out variable anymore, so we can actually delete this. To actually change the name, you want to change it here, and you want to make sure you use the R variable, so that way you're not overwriting the file over and over again. Got an error message. What did I get? Blend width is not defined. Apparently I do need to set this, but I actually don't care about it. This is based on the work that Justin Pinkney had done. He had some other math in there to like actually do some averaging between the various weights, and I just want like a hard split, so I removed that. Let's see if level, so we'll remove level as well, because I don't think we care about any of that. Okay, let's try this again. Yep. So here what it's printing out is printing out what layers we're keeping from the previous network. I believe that's correct. Let's see. Where's print here? Oh, yeah. It's just telling us what layers to look for. And if I refresh my page over here, you'll see here are all of my layers. So this is much quicker than going in and manually like one by one editing your code. So I left this in here if you were interested in using this. All you need to do is edit these values and edit this last value down here as well. And lastly, to actually look at these images, we can use these resolution values, this R variable, and run our generate script. So we can actually just take this same value, and then using the same variable, we can actually like dump these out. So we'll print out a bunch of images. We'll save them to a folder that'll be use our variable, and then we can also load in these images the same way, or you load in the pickle the same way. Make sure your name matches, and then we'll just do -R. So this will basically loop through, and it will generate a bunch of images using that pickle. So then we'll have a bunch of images to compare to each other. So we'll run this. It shouldn't take more than a minute or two. And so here again, this is the 8 by 8 layer. So actually see, this is way more bone than previously was shown when we were looking at the 64 one before, right? So this is like cat faces somehow glued over human faces, I guess. It almost looks like a human is wearing an animal mask. Oh, what's going on here? Why are my images the same? Oh, there you go. That one's a little different. So it's kind of hard to view these in isolation and understand what looks good and what doesn't. So what I have at the bottom of the code here is what we'll do is we'll dump this into a zip file. So we'll take all of the folders that we generate here, the out folder, and we'll zip them all up. And then we can download or move that zip to drive and then look at them one by one. Colab isn't really set up to view images, like that many images all at once. So I generally recommend downloading this and just sort of taking a look at it. But let's take a look at 32. I feel like 32 was the layer that I thought was starting to look good. Yeah, so there's our furry human. Oh, furry children. The teeth are always messed up too. Okay, so maybe between 32 and 64, I sort of like that example. And also, I'll generally say, like, I find between 32 and 64 are generally the right mix for most models. But you may just find that you like certain. Yeah, sorry. Close these down so you don't have to look at these so often. Yeah, so I think like this would be really fun to play with your own models, right? Like we just looked at FHQ or other things, and FHQ is actually a good one to try with. If you want really creepy things, use FHQ as your higher layers, so you can add skin texture to whatever image you have. That will always look very creepy. But also I think like the idea of taking FHQ and applying your own work on top of it, you'll get like these face structures with other things going on inside the faces or the silhouettes. So I think this is a fun technique. Again, once you've got a pickle file you like let's say I liked 64, this is where I would download this or move it to my Google Drive so I could reuse it again. You might also just want to, like I didn't include the rest of the notebook here, but you might just want to like take some of the code from the other like bigger notebook and paste it here so that you don't have to move this thing around at all. And you can just generate stuff directly from here. So that is network blending. Any questions?
Is there like, can you mess up a file at all by using a legacy if it's not legacy or anything like that?
Not really. Legacy will only ever convert forward. So if you run legacy and it can't, it'll just throw an error message. But you can't ever really destroy your source file. And also with this technique, like what you're doing is you're just sort of like copying all the data over. You're not doing anything to the original file. So with this technique, you shouldn't have any destructive stuff. And I say you shouldn't, I mean, you can't with the way this stuff is built. So don't worry about breaking your old files or anything.
Cool, thanks.
If you're using a transfer pickle file, it asks for two models, but you choose one of them as a transfer one pickle, and then the other one is, what is it?
Well, yeah, so here's what I would say is you want to choose your two models ahead of time. So you start with one of the models as your like resume from, and then your second one is your transferred model. So in this case, like what I would do is I would start with FFHQ, and I would transfer bone on top of FFHQ. I would take that FFHQ model as one of the models, and then my new transfer learned bone model as the other one. Or in the case of what I was showing examples before, it was that the geometric model, I would start with the geometric model, I would transfer learn my flowers on top of that, and then I would use those two versions, or like I would use the original one I started with, and then the flowers that I trained off of that. Does that make sense? Cool. Okay. Yeah. Yeah. So this does require a little bit of planning, or like just sort of think about like, okay, what do I want to do, right? And it's helpful to think about like what's the context of this. Am I trying to take the large structures off this thing and the new structures off this one, or vice versa, or like, am I just trying to mash some shit up and see what I get, which is also totally valid. Any other questions? If not, let's take a 9-minute break. So we'll actually 8 now. So let's come back at 40 after, and we'll look at doing network bending. So we'll see everyone in a couple minutes. All right, so were there any additional questions about the network blending stuff we looked at? All right, sounds like a no. So I'm going to go ahead and jump into network bending. So network bending takes sort of a similar concept of just like what can we do at each one of these layers, and does something a little different. Network bending, which I think we looked at a little bit last week during the audio active stuff. We looked at how to do like that sort of scale change with the beat of the bass kick drum, that sort of thing. Network bending is this concept of taking layers and applying transformations at those layers in order to create different effects, right? So in the case of what we were doing last week, we were doing a scale change on a specific layer. And what that happens is that sort of like changes the weights of those layers, and that sort of like echoes throughout the rest of the image or the rest of the data in that particular place. So conceptually, the idea here is like, let's choose a layer, right? Like let's choose, this would be, I guess, layer 4, essentially. 0, 1, 2, 3. Well, this is the 4th layer anyway. It would be an ID of 3 if you're 0 index, but it's the 4th layer. And let's do something at that layer. And in some cases, what we could do is rotate it, right? So let's say we rotate this layer. Now it's important to think about, like, we might think about that as rotating the image at that layer, but what we're really doing is rotating the weights of the model at that layer. And what happens is, even though we're rotating it here, this sort of like passes through to the rest of the layers in the model. And what happens is a really interesting thing where it's not just purely rotating the image, right? Like we could rotate the image and like we'd take the video and put it in After Effects and rotate the video in After Effects. But what actually happens is you get different images out of this because these weights are rotated in a different way. And a lot of times what I find is that things sometimes disappear. Other things appear in weird places. You get just some really interesting effects by doing something as simple as rotating a model at a specific layer. I'll show a couple examples of this, and the way I always think about this is like it kind of highlights what the model learns and doesn't learn, right? Models are specifically, in many ways what a machine learning or a StyleGAN model does, it learns the likelihood of a thing to appear in a certain place, right? So eyes in the FFHQ model always appear in the same place, right? Because it's been fed data that's been aligned. If you were to feed it that wild image that I showed maybe in week 1 or week 2, where eyes are in different places, the probability of eyes appearing in different places is now determined by my data. And that's essentially like a machine learning model like this is essentially a probabilistic model. It determines like what is the probability of a flower appearing in this position, in this color, or in this like texture, this structure, versus in another position. And what happens is when you rotate these weights, you're moving the weights into a place where the next layer of the model might not expect it to happen. It might not expect to see those weights or those pixel values in that position. And it sort of has to be like, well, what do I do here? Like, I guess I render a flower here, but like, I don't know how to actually do that. So it renders this very like sort of distorted thing in this position. And that's sort of what's really interesting about this sort of network bending technique is that by introducing new sort of like positions of pixel values or weights to this model, you get weird results out of it. So let's take a look at what happens when we do rotation. And so you can see here, like this is just using a single image, and that single image is being rotated, and then we're just taking whatever the output image is. And you'll see like this big flower kind of disappears, and it's because, you know, maybe my model has never seen a big flower in these positions before. So it kind of tries to figure out like, well, what should this thing look like? I guess it can maybe look like these other flowers I've seen before, or other things I've seen in those areas that kind of match those weights. So I find rotation to be a really, really powerful transformation. In part because you get this really interesting effect of things sort of appearing and disappearing because of the data this model has been fed. So I think it's really valuable to sort of play with this. Again, you'll sort of you'll learn about what the model has learned in many ways. And there's actually a number of transformations available in this network bending repository. The ones that I tend to play with the most are the pretty obvious ones: translate, scale, and rotate. And there's a demo video here of sort of what happens as you translate things. So translate being move X, move Y. So here's an example of them moving X and Y. And you'll see that like this is FFHQ, which I believe is probably like just better trained overall. Here's the rotation right here. See how weird it gets? Because it's never seen eyes in a certain position. It never expects eye weights in those positions. So the eyes sort of disappear. Here's a scale, right? And so you get this thing of like, it kind of looks like what you would expect, but there's always little weird things going on as well. Scaling up is very strange. Here's reflect. So again, this is just taking, I guess maybe reflecting the weights both directions. Dilate and erode, for those of you who aren't familiar with those concepts, is sort of like it's helping define sort of edges, or it's actually sort of, if you ever use the magic wand effect in Photoshop, it's reducing or extending the space. So erosion and dilate do that. There's a bunch of other tools in here. I honestly like these top three are the ones that I tend to default to. These other ones are sort of like, they kind of feel like Photoshop filters. Like they do something, but like I don't really love the effect as much as translate, scale, and rotate. But yeah, so, and the other thing that you can start to do is you can start to combine these. So you could do something where you can add scale and rotation together. Or you can translate and scale. Like there's a lot of really interesting techniques as you begin to multiply these things together. I actually did, just to make sure that this was working the other day, earlier today, I should say. I did an example here where we have one that both scales and rotates. Let's see if I got it here. This one, I think. So this is starting from a 0 scale and scaling up while also rotating. And like some of this you just get pure noise, which is kind of fun. But then other times you get these sort of moments where like, I think this is quite beautiful, right? Like you can tell it's rotating, but this isn't any data that's in my model. Like the data I trained it on, this doesn't really exist in there. So now we're getting to a place of where, again, this is sort of what's really important to me from like a machine learning art model is like, I'm not just reflecting the data that I trained it on. I'm starting to create new things that didn't exist previously. And I think this is a great example of sort of that experience, right? Like you get this sort of beautiful swirling effect as these things sort of come in and out of space. So I really love this technique. I think there's a lot that you could do to play with it. And there's a lot of interesting things that your model will act differently than my model. So much of this is model dependent in a really weird way that like, it can be like kind of confusing. Like this again feels almost like feature vectors where you kind of have to do a ton of different transformations, see what they look like, and then choose your favorites and then work off those. So if you're interested, this was a part of this was essentially, I believe, a master's or maybe a PhD project from a guy by the name of Terry Broad, who is in London, I believe. And the paper for this is fairly readable. I recommend reading the paper. I'll link to it. Let me add a note here as well. Link to bending paper. But he also did a really great job of, he created this drive folder of a ton of different transformations, as well as like what the unmodified images look like So in this example, here is like seed number 9. And he applied a bunch of various transformations to that image. So like that's the unmodified version. So let's go in and look at maybe what scalar multiply -1 looks like to that image. And then it also applies to every single layer, right? So you've got both the transformation, but also then what happens at every layer if you do the transformation only on a single layer. And that's where this gets really complicated. Like you're starting to multiply all the various effects. One thing I'll say is I just generally find that the effects work best on lower layers. We can look at them. So let's look at layer 1. And we'll look at what happens. So this is a scalar multiply, which I don't know exactly what that does, but this like distorts the hell out of this thing. That's kind of cool, actually. Everything looks like kind of wavy. So this is a scalar multiply that's applied to that image. This is at layer 1. If I look at it at layer, let's say layer 3, you'll see it looks a little bit more structurally like a human, but now there's like all sorts of messes in the middle. And this is, again, remember that each layer is sort of assigned a different weight of structure versus detail. So when I apply this a little bit higher up the network, I get a little bit more of this is what the face structure should look like, the outline, the silhouette, but everything in the middle is kind of murky. And then if we jump all the way up to, let's jump up to like let's go to layer 12, which is a very high layer, and we look at what happens here. We get a really interesting, like almost inversion effect, where like most of the image is good, but then there's this like the fine details are sort of inverted in a really interesting way. And if we jump to the very top layer, which I believe is 16, you see you get like almost like a solarized effect. So for me personally, I tend to find that the lower layer stuff does more of what I would expect it to or what I want it to do. But you can play with this and sort of find what works best for you. So I might recommend just digging through this whole folder. He's made this publicly available just to sort of see what happens with each of these different pieces at different layers. So there's also a blate, which I believe a blate is just like basically like erases that layer. So if we were to go to a middle layer here, yeah, you just get interesting textures. So again, I would probably like just dig through this and sort of see what's what. The other thing that is important to note about this, I should link to this in the class notes as well, is network bending. If you're interested in exactly how to use these or like what the values are for these, down here at the bottom of this section, this will tell you that params takes in a float x and float y with a range of -1 to 1. So -1 on the x dimension would be all the way to the left, meaning it's off the screen to the left. +1 would be all the way to the right off the page. So it's kind of helpful. You have to know exactly what these values also mean. So scale takes a 0 to an infinite. Rotate can only take 0 to 360. So when we start to look at animations, we have to do some hacky stuff to make sure it stays within this range. But all of these have different values. Flip H, flip V, invert, and ablate don't take in parameters because if you set this, it's just saying true, like do this. So just be aware that like all these have slightly different variables. We'll show how to edit this or how to add these in the notebook in a minute, but it's just worth sort of looking at this. I'll add this here just for people to look. So let's go back here to my notes. So yeah, I would definitely like, this is one of those things that feels a little bit like feature vectors, where you just want to generate a lot of stuff and then dig through it. And then maybe once you find things that work best for your model, you'll go through and play with them from there. Yeah, so one other thing to mention, and we'll look at this in the notebook when I dive into it, there is in fact yet another set of layers in the model. This is what we looked at last week with Audio Reactive, where we're using the noise layers in the model to generate a little bit of that textural effect. Noise layers exist twice in every single layer of the model, except I believe they only show up once in the 4x4. And that is, again, it adds a little bit of that textural detail at each one of these resolutions, right? So the thing about that is if you've ever done, what's the best way to describe this? If you've ever done like upsampling or upsizing in Photoshop, you know that stuff tends to look a little bit blurry. So you add a little bit of noise into it to give it that texture back, right? Or maybe sharpen it a little bit. You can think about that similarly as what's going on here. Each one of these layers gets a noise layer added on top of it to give it a little bit of texture. So we'll look at how to manipulate that as well. One of the things that I tend to find, especially when you're doing that rotate function, is if you don't change your noise layers or interpolate your noise, you'll often get textures where like the image moves, but like the texture on top sort of stays the same. And it almost feels like there's like a saran wrap like kind of thing over it, which can look a little funky. So I added some additional features in here to do some noise interpolation. We'll look at that in the notebook in just a second. All right, let's go ahead and take a look at this and we'll walk through it. So I'll copy the link to this for folks. I already have this open somewhere. Where is this? Here we go. All right, cool. So one thing to note about this particular notebook is we are using that Rationality PyTorch version. So just be aware that if you haven't already converted your notebook or your model file to that .pt version, you'll need to do that for this. This is not like sitting in my repo. This is sitting in sort of an additional step. So I went ahead and ran this already just so we were set up to go, so we weren't sitting here for a couple minutes. Another thing to note is that this requires a specific version of PyTorch, which means we have to uninstall PyTorch in Colab and reinstall the right version. So this takes 5 to 10 minutes to do. So I didn't really want to sit here and wait for that to happen. So I went ahead and ran this during our break. But just know that it takes a couple minutes to get set up. So what you'll do is you'll check to see what GPU you have. You'll install all the code for this and uninstall PyTorch and bring it back on. And then you'll want to download your PT model. So again, you can convert that using the notebook that's linked here if you want it. So I've went ahead and done all this. So now I can go ahead and just generate some images. So the first thing, the way that this notebook works, if we break this down and look at this here, let's look at, just add this here, -- help. So there's a couple things that we need to look at. So first off is CKPT is checkpoint. So whereas previously in many of the notebooks that I've done, you'll see network equals. We just want to use CKPT here. The other thing that's important is the config file. So we'll look at a config file in just a minute. The config file determines all the transformations we're doing, what layers we're applying them to, how much of a certain transformation we're doing, that sort of thing. So for this, you will really want to make sure you're editing your config file in the right way. And there's a couple other things in here that we don't really need to worry about too much. So also what I recommend doing is, because this is not the official PyTorch model, I also recommend that you run this script first just to sort of see what your images look like. So what is this going to do? This is going to use my PT model, and it's going to generate 400 pictures or 400 samples. This is sort of a different way of saying seeds equals 0 to 399. And then config, this is actually going to point to an empty configuration file. So we're going to say we don't want to do any transformations to our image whatsoever, and then we want to save all those out. So I ran this. And they are here in, did I run this? Nope, I didn't run this. This didn't work. Okay. So I'm actually going to make this a little bit smaller. Instead of doing 400, I'm going to do 50. One of the things that's important to this is, this actually might not work the way I expect it to. Let's see. So this will generate a bunch of images. This just helps me know that my model that converted works well, but it also sort of gives me some images to work off of. One thing to note is that this particular model doesn't use seed values in the way that our other models use seed values. I may actually add that in the next week because I kind of found it annoying that I couldn't do this. Everything is random, meaning your images are always random, which can be really frustrating to work with. But here is all of our images. So we have a couple images in here now in the sample folder. So there's one of my flower images. Now remember, there's no transformations applied to this, so it should just look like one of my normal model images out of my model. And you can zip those up, download them if you want to. So let's take a look at how to actually do some bending in this repo. So first thing that I recommend doing is you'll just copy over that config file. So these config files live here in configs, and they are what's called a YAML file, which is a little bit like a JSON file, a little different, whatever. You'll find that as we get into the weirder and weirder corners of StyleGAN repos, everyone has their own way of working, and we have to sort of like decipher how they work, and then we have to use that or build our own thing. So I'll often just decipher how they do it. So I'm not building a ton of new stuff from scratch. But these YAML files contain all of the configurations that we're going to do for our network bends. So we'll go ahead and run this. This is going to copy that empty version and create a new one called custom. And then we'll use the thing we looked at last week, which is to be able to use our collab cell to actually write to this file. And we will add in all of our transformations. So the first thing you want to do is at the very top of the page, or the top of this file, you'll add a thing called transforms. And then inside of that, probably the easiest thing to do is just to keep the code that's here and edit it as needed. You will have a different transform with different commands at each point. So the first thing you'll notice is that we have a layer. So this is what layer of the model are we applying this transformation to. One note is do not use layer 0. That is the 4x4. Because it's a constant layer, you can't really edit it. So don't ever use 0. I recommend just using 1 if you really want the lowest structural change. You'll do that here. If you have a 1024 by 1024 model, I believe this goes from 1 to 16. 16 being that very, very top layer. I tend to keep my things of lower structure, so like 1 through 4. But you can edit that as you see fit, maybe play around. So we'll set this to 1. We'll do a transform of rotate. And we'll do a parameter of 45. So we're going to rotate this image 45 degrees. So this is where this stuff here comes in handy, just to make sure that you remember the things correctly. So these are all the transforms you can use. So transform, scale, rotate, erode, dilate, scalar multiply, binary. I believe this is binary threshold. I don't know if that's spelled wrong or if that's actually correct, but it should be binary thresh, I believe. Flip H, flip V, invert, ablate. And then all of those can be assigned a layer. So we've got layer 3, translate. And then our param is the actual difference. We're going to change it. So remember, rotate takes in degrees between 0 and 360. So we'll do 45 here on the first layer. Then we'll do a translate of -5. So that is half the distance of the width. So if it's 1024, we'll shift it to the left 512. I could also shift it, if I want to shift it up, I could do a negative value. So I want to do, if I want to shift it up halfway, I could do that too, 0.5. Let's do a quarter of the way up, so we'll do 0.25, and that's going to be applied to layer 3. This features all, don't really worry about that. For this class, I recommend just leaving it at features all. So that's probably why I recommend just like copying and pasting these and editing things as you see fit. And let's say scale. So we want to make the image 1.5 times larger, so we'll do 1.5. Another thing to note is you want to make sure all of these are floating numbers. So this is fine, but you'll get a warning message about it. If you do 0.0, that'll just be floating, and then you won't get a warning message about it. So just for most of these values, you want it to be 1.5. Excuse me. Let's also look at one of these other ones that doesn't take in a parameter value. So flip H doesn't take in a parameter value. It just applying it just says that's true. So let's go ahead and add that here as well. So we'll do dash space layer. Let's apply this to a high layer. Let's do something like 15. And then params, or sorry, transform. It's flip H. And this takes in a params of, I believe, just empty brackets. And then we also have features of all. Okay, so once I've written out all the transforms, now you could also do multiple transforms. You could use rotate more than once. If you want to do a rotate of maybe say another 45 degrees at a higher layer, like let's say 10, you can do this. This all works together. So these compound. The other thing that's kind of important is I believe order matters. Like if you were to switch the order of these things around a little bit, I think you would get different results, but depending on layers. So you may want to play with that and just sort of see what happens. So I've added a bunch of crap in here. I don't think these images are going to look good, but we can just run this and see how it works. So the first thing you want to do is you'll run this cell just to make sure that you are saving out your config. And then we can go ahead and run that on our actual images. So again, we'll use our checkpoint. We'll do 10 picks. 10 of our images at this size, we'll point to this config file. So make sure that it knows like these are the transforms we're going to do, and we'll save it out to a directory called custom samples. Let's go ahead and run this. And if I refresh my folder, I'll see custom samples, and I can look at one of these images. So it's really hard to see what's happening here, right? I can tell that something's been rotated 45 degrees because I can kind of see this black box that's been rotated. I assume there's been some sort of shifting here, but I couldn't tell you what it is. This is where, you know, it's a little bit of just like, I tend to find that if I'm just doing examples and just trying to test stuff, it's easier to isolate and just do one transform at a time rather than doing like 100 transforms and trying to figure out if that looks good. So you might want to start with one and then build up from there. But we will see like all these work. Like I would assume that all this worked and we didn't get any error messages. So clearly something happened here that was correct. So this is how to generate single samples. Yeah, so we'll see there's a flower in the corner there. It almost looks kind of Art Deco-y with the weird angles and stuff. Kind of interesting. So that's how you can just generate individual samples. And that might give you a good way to just sort of like test some stuff, right? Like loop through a bunch of different transformations, see what happens to your model as you transform things. There is also a command called sample strips. What this will do is it'll give you if you apply a single transform, it'll generate a strip of images that shows you what happens when you apply that transform to layer 1, 2, 3, 4, 5, 6, all the way to 16. So the way to do that is to create another config file. And this config file, you don't use the transforms and then the dashes and things. You just give it a single parameter. And this can only take one transform. So you can't add multiple transforms in here. So just do rotate 45 degrees and apply it to all. And what this will do is it'll iterate over your samples and generate at for each sample what it looks like at layer 1 through 16. That way it'll sort of tell you like, hey, what layer should I maybe be playing with this value at? So I'll go ahead and save this. And then I'm going to make far less pictures so we're not sitting here waiting for this to render. Go ahead and run this. This will definitely take a little bit longer to render because it's generating multiple examples for every image. So it's to kind of like loop through all that. But we should get a strips here down here. So if I go ahead and download one of these files, these are huge, they're very, very tall. So like I recommend downloading them just to look at them. All right, and zooming in just so we can look at this. So this is one of my images rotated 45 degrees, and this will show me every single layer example. So remember how I said layer 0 doesn't do anything? This is layer 0. It's just going to be your main image. This is 45 degrees rotated for the layer 1, layer 2, layer 3, layer 4. Here at layer 5, we start to get these interesting sort of corners included. And then layer 6, all of a sudden we're getting new colors at layer 7, layer 8, we're getting new colors. Now this is because, right, if we rotate our image at this layer, there's all this like corner detail that like the model kind of doesn't know how to produce. So it kind of just generates noise in those corners, and then we get these really interesting sort of noisy effects. And going all the way to the top where like we're seeing like some colors in those corners, I guess. So again, remember that this is not cumulative. This is just isolated on an individual layer. So you have like just layer 0 all the way down to just layer 16. So just layer 16 should pretty much be just your image, and then there will always be a little bit of coloring in these corners. This will generally happen for pretty much every model because this is just that very, very fine layer that's been rotated. So just very little change. It's basically rotating our main image with a little bit of like other stuff going on. So you could play with this. You could edit this cell to now be scale. You could say scale of 1.5. You could run this again, and then you could see all the examples of scale. So again, there's sort of like, this is one of those places where if I had more time, sitting down and actually like writing a script to auto-generate this stuff, or like to pull these into grids, would probably be more helpful to visualize. Instead, we'll have to do a little bit of manual labor to like generate, download, generate, download, generate, download, that sort of thing. But I find this is really helpful just to sort of set up, just so I know how things affect my model. You know, maybe you find you really like scale at layer 8 in your model, and therefore you sort of keep that in mind as you're doing other things. Or maybe you find like, oh, I actually really like how this other thing works, or whatever it is. So it's sort of nice, just sort of set up. Again, it feels like feature vectors, right? You kind of do a lot of work just to understand what's going on, but then once you've got that, you can sort of reuse those pieces over and over again. Any questions about just generating images using this technique? Okay, and as I'm sure you're wondering, well, like that's cool and all, but like how do I generate like animations, right? The idea of an animation being, I actually want to iterate over that value, right? So I've got rotation here. If I do rotate 45, what I really want to do is I want to, over a whole, like let's say over 10 seconds, I want to rotate this thing from 0 to 360, right? Like that would be a goal. So then it loops sort of like in a circle. And so you can do that with this. This is the script to do this. So let's break this down again here as well. I think this is where I'm going to run into issues, but let's see. Okay, so a lot of this is set up in a very similar way, except there's no config file this time. We're sort of skipping the config file, and we're doing it directly from our command line here. So we'll point to a checkpoint. This load latent is, you know what, I'm going to go ahead and edit this already because I think this is going to become an issue for us. Essentially what we need to do, where is this code going to be? Give me 2 minutes. I need to figure out how to, oh, you know what? I know where to find it. I was messing with code and I realized I kind of broke something previously today. So let me go back and edit this real quick. So one of the challenges with this particular repo is because it doesn't use seeds, you have to save the latents in a different place. So I'm going to just go back, network bending. How do I view this in? Dusk or someone who understands Git better than me. How do I find the, like, actually look at the file from this commit? Like not the change, but the actual,
So
what happened when I committed at that time?
If you're on like this commit at the top, you can click on the browse files and then you have to go find the file and then it'll show you like the state of that file.
Ah, yep. Okay, perfect. That's what I wanted.
Yeah.
Yep. Thank you.
Oh, you know what? I'm looking at the wrong file. That's why. Okay, generate. So I want this code. Sorry, y'all. I just need to do this real quick, otherwise this thing won't work. So that goes at the end of the generate command. That looks good. This save late here. All right, sorry about that. So to go back up a step, when we generate our images, there's also a command to save out our latents. If you set it to 1, that means it will save it out. If you set it to 0, that means it won't save it out. So I'm going to go ahead and run this again. What I'll show you is what's different is that right now I just have a bunch of images and then a config. And that config just tells me what I ran. So if I run this again, okay, that's why right there. This time what it's going to do is actually going to take all of the vectors for each of these. Latent dict is not defined. Okay. Here we go. This guy. So because the system doesn't use seeds, we don't actually know what 0 is as a vector value unless we run this save latent code. So when this reruns, come on, for real? Because I don't have a dir. Dash dash dir equals / sample and add a slash here. Let's see if this works this time. Okay, what am I doing wrong here? Let me look at my code. Oh, because of this. Okay, I'm just gonna hard code this in. I'll fix this for everyone so that later tonight you can actually run this and it won't break. Sorry about this. Okay, there we go. So if I refresh this folder, you'll now see I also have a file called latents.yaml. And if I double click in here, you'll see that each of these is indexed, and this gives me all of my z values. So what I'm going to do is I'm actually going to be able to interpolate while doing the animation. I'm going to be able to interpolate between these values. So what I need to do is I actually need to reference this file, which is why I realized I fucked up and needed to generate that file. Because when we do animation, what we're going to do is we're actually going to load in that latent file, and then we're going to, we can skip this part. I think we just set this to 0. We're going to use those latents, and we're going to provide some IDs here. Now, I think I only made 20 of these, so I can make this a smaller value. These values have to exist in this file. So I think I only have, if I scroll all the way to the bottom of this thing, I think I only have 19 of them. Yeah, I've got 19. So I can't use a number higher than 19. But the helpful part here is, and I should have noticed that this is wrong before, all of these values, like this image, now matches to a actual seed value or a latent value. So if I really like image 4, and I want to interpolate from image 4 to image 19, I can do that using this code now. So make sure that when you save out those latents, you've got the latent file, you're going to take the path from here, and you're going to paste this into the load latents path, and then you're going to use the interpolation IDs from this. So you can go, I want to go from this image to this image while also doing these transformations. So then you can do number of frames. So I'm going to make this much smaller so we're not sitting here waiting forever for this thing to render. And then you'll pass in the transform. You'll pass in a starting value and an ending value and what layer you want to apply it to, right? So let's say I want to apply this to layer 1, and I want to go from, let's say, 0.5 to 2 over 72 frames. Something to note is that in this version, you can only do linear. It's only a linear transformation. There's no easing or anything yet. Maybe that's something I'll add in the next couple weeks. But you'll just go from a scale of 0.5 to 2.0, and you also like truncation values, some other things, and then where to save these images. So let's go ahead and run this. And this will just run. So while this runs, let me go ahead and also talk about how you can do multiple transformations. You can do multiples. This gets a little bit trickier. So the deal is basically you do the exact same thing. You're sort of referencing this model. You're referencing your Z seeds that you're looking for. We'll set this a little bit smaller again. And then this time what you do is you can feed in transformations in an order. So we'll do scale, and then we'll do rotate. And then for every one of these things, you need to also make sure that your values match up as comma separated, right? So what we're going to do here is we're going to go do a scale change from 0 to 2 on layer 3. And then we're going to do a rotate change from 0 to 360 on layer 1. And I could add more. I could do another scale. And I could say, let's go from 0.5 to 1.0, and let's do that on the 10th layer. So all these are comma separated, but you have to make sure they match up correctly. So this can get a little gnarly. This is again a place where GUI or other tools would probably be a little bit better, but for the moment this is what we have. So this will allow us to do all of these transformations all at once, so we can look at that. So this looks like this is just rendered, so why don't we run this while we download that example. Got an error message here. Invalid float value. Interesting. Okay, 1 second here. Let me download that video real quick. And let me fix maybe the bug that's in here. That's why. I fixed this somewhere. Why are... man, terrible demos today. All right, let's see if this works now. Apparently I didn't push all my code, or I pushed it to the wrong fork. Let's see. Okay, this time it's working. All right, so let's take a look at that scale video and just sort of see what we got. Okay, so this is way too fast. This is one of those cases where I would probably do this much slower, but it is scaling up. It's kind of maybe hard to tell because of how this interpolation is happening. One thing you might want to do is to look at these without interpolation. A hacky way to do that would be to, instead of interpolating across like all of these seeds, what you could do is you could actually just remove this and just go 1 to 1. The way this code works is you do need more than one, so you need at least two. So this way we're just saying like just stick with one. And then let's render this out real quick. So what this would do is it would give me the same image and it would let me see what happens as I animate just that same single value. So this might be, again, a good way to sort of build up sort of your layers of different changes. You might just want to start with a single seed value, see what happens as you animate that scale shift, and then begin to layer in interpolation and other techniques. Let me come over here and look at our multi-scale test. So this is the one we're doing scale, rotating, and scaling together. That looks all sorts of weird. So you got this like kind of funky little border while the image is rotating in that space. Yeah, the texture of the border is cool. It's kind of got that like 80s Memphis vibe to it. It's kind of interesting. So yeah, so that is doing multiple things together. Now the last thing I'll mention is, and I mentioned this before when I was talking about noise layers, there is a way to also interpolate your noise. I don't really have a good example like offhand, but one thing you might notice is that in some cases, like actually maybe, I'm interested to see maybe the noise interpolation will actually change this noise in my border, and maybe the border will actually change a little bit. But sometimes you'll see that like the details and the textures, I'm pointing at my screen like you can see what I'm pointing at, but like some of the texture in the flowers will stay the same, and it'll almost feel like it's a saran wrap layer like sitting over top the image. And if you change the noise, you'll get a little bit of a difference, or like that noise will move and things. So this is one of those things that Hans Brewer, like him and I were chatting, and he was like, you really have to start interpolating your noise, because I can tell that you use static noise in all your images. So I went ahead and started to build this in. So the way to do that is here, is you can just add noise underscore interpolation, and that's going to add some noise interpolation to your model. So we'll go ahead and run this and see if we get anything different. Actually, I want to use that same scaling technique and see if we get anything there. So we'll grab all of this. Yeah, so let's run this and see what we get. While I'm here, sorry, I'm jumping around a little bit because I'm running out of time. I'm bouncing between these two, so I hope it's, what did I break here? Maybe this, maybe this, definitely this. Okay, so we want to change this. Let's see if that works. Yeah, that works. All right, so now I'm going to go back to my other example where I'm doing the scaling. Sorry, I know we're bouncing around a lot. Hopefully the recorded video, you'll be able to sort of stop and be like, what the fuck is he doing now? So this example is just a single image that we're then scaling up. So what I think is really cool about this effect is, again, in Photoshop, if we were to just scale up a video, we would just get the same texture no matter what, right? It would just get the same video like scaling up. This, when we take the same seed value and scale it up, we actually get different results. And you can sort of think about that as like, remember that each of these is a pixel value or like a weight at a lower layer. And that lower layer, as it scales up, is being interpreted by the rest of the layers. So you actually get a different image as you scale up. Right, so the flower is kind of moving and other things because the weights in the lower layer are now being interpreted by the higher layers. So I think there's just some really cool effects you can get with this. And this is one of those nice things where like it works well with these flowers, but it would also work well for more abstract things. Like I think you would just get really interesting results just playing with this. Let's see if this one rendered. I believe it did. All right, so let's see if our noise did anything for us here. Oh yeah, this does. So see how the background, see how the texture is kind of changing? So that's because of that noise interpolation. It doesn't change a lot. It just looks like it's maybe changing scale, like you're getting less. But I bet we could do something with that by changing the way that we interpolate stuff. So that's a side effect of sort of the noise interpolation. But if you were to actually sort of watch this video and compare this compared to one of the previous video we looked at, you would actually see that these textures in the image in the flower itself are also changing. And that's, again, remember that noise changes some of the detail of an image. And I found in this particular model it also changes a little bit of how various of the smaller like parts of the leaf grow and don't grow. So yeah, so that is network bending. I apologize for the 10 minutes of me copying and pasting code in the middle of this demo, but I would definitely recommend, I'll fix all the issues that we were running into there, so we've got them. I would definitely recommend playing with this, especially with your model, just even if you want to render those strips and see how your model reacts to things like scaling and rotating. I think is going to be really, really interesting. And if you want to play with some of the video outputs from this as well, I think it'll be cool. So any questions about network bending?
I got a question.
Yeah.
When you are scaling the weights or rotating the weights, you're leaving blank spaces where weights used to be in that tensor, right?
I'd have to look at the code that is using in this repo. I think they might be doing some padding, but I would also think that maybe that rotation issue was that they aren't actually padding those tensors correctly, or they're not doing it all. So I know that like one of the differences between say this and the network bending that goes on in the audio reactive notebook is I think he's doing a lot more padding of those values. So you might get different results depending on which notebook you're using and what code you're using. Does that answer your question?
Cool.
Okay, yeah.
Give me a heads up, a head start to getting a full answer.
Sorry, that was a little hard to hear. Oh, my connection is bad. Not sure I caught that, Grant. Do you want to just type it in the chat? Okay, cool. Yeah, that's fine. Yeah, I'm also having connection issues, so it's not just you. Any other questions? Okay, so I can stick around for like 15, 20 minutes if people do have questions either about this or about other things. One thing I do want to remind people is that I don't have anything specific in mind for next week. So if there's stuff you've seen that you've seen other people do with StyleGAN or with other things and you want to discuss, I'm happy to look at that. Like I know, Adam, you mentioned some of the folks in the clip world are doing stuff with like fisheye lenses, and those are also using sort of a similar trick like this where we might be able to do, we could try taking one of their little pieces of code and seeing if we can drop it in here and see if it works. My guess is that knowing how they built it, it's probably going to work easier in the audio reactive stuff, but we can try it and see.
Yeah, that'd be cool.
The other thing that I think I mentioned this maybe to Nauco and maybe a couple others. There's another model called rewriting. Let's see if this shows up. Here we go, rewriting. So I think Nauco and I were discussing that, like, you know, both of us use a lot of abstract models, and sometimes doing stuff like feature vectors like is really hard because it doesn't really map to an abstract way in which you can work with things. So we were looking for other tools that can do abstraction stuff. And there's this thing called rewriting, which I think is maybe interesting or could be fun to play with. What this allows you to do is essentially like almost create like Photoshop style things. So there's a thing where you can like copy a certain area of an image and then paste it into the model. And this again works, I believe, on both a layer side, but also like in other ways where it's not just like cutting and pasting like you would in Photoshop, but it's actually changing the weights in the model so that now you can render, let me just open this in a window so you can actually see. So in this case, you can like say, I want to copy this tree, and then I want to be able to paste it into this like church scene always as the spire. So now like the model has learned that it can render trees as spires. And they have other examples here. I believe there's another one. Let's see if I can find the fun. There's a mouth one where I guess you can force mouths to do certain things. Here's another one where you can remove windows and replace it with brick. Where's the hat? This is the one where, this is where they put hats on horses. They cut a hat out of this scene, or they like reference it, and then using this, they're able to train a way to add hats to horses. This hat looks terrible. So kind of funny. So I think I haven't really used this model before, but I could see what I could do between now and next week if people are interested in sort of playing with this. I think it's gonna be fun because you could do more abstract stuff, right? Like copy a patch out of an image, place it in a new place, and then almost generate like collages. But the nice thing about this is it's not just gonna like collage it like in a hard pixel way. It almost sort of like renders it into the scene in a way that's like not perfect, but like kind of fuzzes it and like blends it in. It's almost like what is it, like context aware tools in Photoshop. It gives you a little bit more of the textures are right and that sort of thing. So we could look at playing with that. We don't have to if people have other suggestions. Yeah, horses have terrible fashion sense. These are the worst hats. They should at least be wearing like a Yankees cap or a Mets cap or something. But yeah, so we could look at doing something like that. We could probably find other models if people are interested in playing with things. Yeah, so I don't know if anyone has any suggestions or things they want to work on. If you do, feel free to speak up either now or just drop a note in Slack with like, hey, I saw someone doing this thing. Could we figure out how to do it? I'm happy to do that. Next week will mostly be like, this might take the whole class or might take an hour. I don't really know. We'll sort of see how it goes. But if people have other suggestions that they want to learn, I'll try to like jam in as much as I can in next week. Questions, thoughts? All right. So I guess we'll call that a day. So I'm going to fix the code for this notebook just now, like right now. Actually, I'm going to go eat something and then I'll come back and edit it. So like in like 30 minutes or so, I think it'll be up. Let's say an hour. In an hour or so, this will be updated. So if you want to go ahead and play with it, you can. So I'll drop a note in Slack when it's ready to go. Yeah, and if not, I'll see everybody next week. Cool. All right. Bye, everybody.
Thanks.